Hello everyone, I'm delighted to be here. It's my first time. It's a very nice event. As you can hear, I'm French. I work for PwC Luxembourg. I'm the head of the incident response team. I've been doing a lot of penetration tests as well as incident response. I already published some of my work, which is a bit various. One important thing is I just presented this talk at DEF CON this year and HackerU, but I'm not going to replay just to repeat everything. If you want to have a look at what I shared at DEF CON, feel free to have a look at those QR codes. I prepared some exclusive content for you. So I'm going to explain what we need just to discover what I made just for this edition. Again, after my presentation at DEF CON, I've been contacted by Palo Alto, who reacted, and they wanted to discuss with me about the things that I found. And this is what I presented to HackerU. So if you want to have a look at what they shared, you can have a look at the HackerU video, which is already online. Yet I will also explain what is the outcome of the discussion with them. And they are the only ones who contacted me after my talk. But for today, I decided to do a kind of more explanations about the tools that you can use in order to reproduce my findings, maybe. And also, I will be speaking about specific issues. In my original work, I wanted to find all the generic attacks that could work, but with my research, I managed to find some issues that are very specific to each vendor, and I'm going to give some example as well. So, a little bit of background. This talk is really for red teamers. If you encounter a network, a company, an infrastructure where they have VPN always on. So the idea will be that I want to share some bypass, some techniques so that you can avoid this kind of control. And for the blue teams, then you will learn the weaknesses of this control and try to improve the situation. One very important thing is we will be speaking about establishing some tunnels, C2, bidirectional channels, and so on, as well as doing some exfiltration. And I really don't want to use very slow techniques based on screenshots, QR codes, light emitted, and this kind of stuff. They are funny, but I really want to have something that is super convenient, fast, and reliable. So we are only going to use common tools from a Linux attacker machine, for instance. And from the victim side, if you are admin, it's just too easy. So we will consider that we are just a normal end user, and that most tools are hardened on the machine. So we will need to find some attacks that work without privileges, and if possible, with avoiding to add some new binaries, some new programs to the machine. So we will need to find some attacks that will work on any standard Windows machine, for instance. A few basic concepts on VPN always on. So the idea is if you have some remote people that need to work, then they will connect through the internet to the corporate controls. So thanks to VPN always on, they will be forced to be connected to the gateway onto the corporate controls. So this is what we want, so that we can monitor and protect them as much as possible. We have the few notions there, split tunneling, full tunneling. On what we are interested in today is always on. So it's a kind of a lockdown mode, where you have no access to the LAN whatsoever. You are just forced to connect to the VPN gateway. So for this research, I wanted to do an overview of the most common, the most popular editors. So I selected Cisco, Palo Alto, and Ivanti. But what I'm going to explain is most probably applicable to any other VPN agent vendor. Another very important thing, we are working on the situation where the tunnel is not established. When you do not want the tunnel to be established, because this is where you will, this is how you will be able to try to attack the device, the target laptop, or if you are in an insider scenario, then you do not want to have this tunnel established because you will want to do some exfiltration, for instance. If you want to have a look at some interesting research about what could be done after the tunnel is established, after the VPN is connected, then I suggest you have a look at Tunnel Crack, which is a series of attacks that were demonstrated published by Matt Ivanov. So, enforced always on or lockdown. This is some symptoms, classical symptoms that we have there. You have, when we try to do some ping, you do not have the gateway is not reachable, you do not have any issues like that, you have general failure. This is a kind of typical symptom of always on because you have some network filtering in place that will trigger this kind of weird behavior. So if the tunnel is not established, like for this example with the Eventy VPN agent, I'm not putting my credentials, so the tunnel is not established. I obviously do not have access to apparently anything. I cannot go on the internet. I don't have access to the LAN. I cannot ping anything. So I'm really blocked. I don't want to be blocked. I want my connectivity. I want all the network access that I need in order to do some data exfiltration, in order to establish my C2 bidirectional channel or whatever it is. The scenarios that I considered is either you are in the middle, you have no physical access to the device that you are targeting, but since you will be controlling the network to which this device might connect, then maybe we can find some attacks that will allow us to unlock the connectivity. The other scenario is an insider or a compromised device already, so you can already execute some code on the device, or you have your hands on the keyboard. So this is the kind of insider scenario, and we will see that having the possibility to type in some commands will of course unlock some possibilities. Another very important aspect of this research is there is no point in trying to bypass this control if you can plug a USB thumb drive, if you can print everything you want. So it's really a matter of attacking a device that has been properly hardened. So let's say that the corporate, the organization that you are targeting is already doing TLS interception. They have data leak protection in place. You are not admin of your machine. So everything, let's say it's almost the worst scenario for a red teamer. This is where I want to find some attacks that would work. And again, I want to find high throughput possibilities. I don't want to use some weird QR codes techniques or electromagnetic diffusions, this kind of attack. They are interesting, but not reliable enough for our scenarios. So let's have a look at how it works in practice. The two main concepts here are TND, Trusted Network Detection. Of course, the local VPN agent must understand if it is necessary to connect to the gateway or not. So it must find some algorithm, it must have some way to see if we are already on the LAN or not. And if we are on the LAN, of course, we do not need to connect to the VPN gateway. The other aspect that we will attack is CPD, Captive Portal Detection. So you know when you are outside, if you are in a hotel, if you are in the airport, maybe you need to connect first on a web page where you might need to pay or you might need to give your identity before you get access to the internet, for instance. So the local agent must compensate for that. It's a kind of a compromise of the security. It will allow you only to connect to this web page before trying to reach out to the VPN gateway so that the tunnel can be established. Maybe the most important slide of this whole talk. Most of the settings on troubleshooting information can be found in this location. They are all reachable by an end user without privileges. So even if I'm going to demonstrate how it works and so on, you will probably find everything you need to understand how to bypass VPN always on just by looking at the values that are in these settings. And you will see that sometimes, especially if we consider some split tunneling exceptions, you may find already everything you need to do some data exfiltration without having to bother that much about how VPN always on works. Captive portal detection. So I need to explain a bit how this algorithm works. Most editors already implemented their own kind of algorithm, but most of the time it's very similar. It's almost always an HTTP GET request to one of their servers, and depending on the answer, they will consider that, oh, okay, you have a direct access to the internet or not. So if these tests fail, then it is considered that we have a captive portal on the network, to which we need to authenticate maybe, or to give some credentials or identification before we can get access to that. All the VPN agents that I tested rely on a combination of these tests to see if there is a captive portal on the network. And as you can see, there is nothing that is actually authenticated, so we can trick these tests. Okay, so we had a look at trusted network detection, we had a look at the settings, the event logs, and the captive portal detection, how it works. So even if we do not understand exactly how it is implemented, and we do not need to do some intense reverse engineering, we can already imagine some attacks. So let's have a look at this. The first one, the VPN agent needs to find the IP address of the gateway. So obviously DNS should be a protocol that should be usable even before the tunnel is established. So we can try to use that. But more importantly, maybe it's not exactly DNS that is important. Maybe we can simply use the whole a whole payload on UDP 53, for instance. We maybe do not need to comply with the DNS protocol in order to exfiltrate some data. And we will get a much higher throughput by doing that. So I'm just proposing a few lines of PowerShell. Again, I try to not having to use another binary or whatsoever. So you can definitely try to establish a tunnel on UDP 53. And it works, but not for all of the agents that I analyzed. It works for Cisco and Palo Alto, but it does not work for Ivanti. So the idea was good. It's a very naive attack. It works, but we already found some discrepancies between the agents. This is something that we will try to investigate after. Another kind of attack, captive portal detection. Since I can trick the local agent that I am a captive portal, or that there is a captive portal on the network that I'm providing to my victim, then these agents will consider that, okay, maybe we have a captive portal somewhere, and it will unlock a lot of possibilities already. Because if there is a captive portal and I pretend I am a captive portal, it's just a web page. So I have all the HTTP features and sometimes more, WebSocket, WebRTC. So maybe I already have a lot of the features that I need to exfiltrate some data, to do some social engineering, try to get the password of the user, and so on. So I wrote a very naive captive portal script, and as you can see, I can ask for the username, the password, and then I can also try to put some form to exfiltrate some data. What is important to see is for Cisco, indeed, the captive portal detection can be disabled. By default, it's 5 minutes of unlocked access, and then all the connections must be done from the embedded browser. For Ivanti, it cannot be disabled. That's one thing. It's not restricted to the captive portal IP, and we have no restriction on protocol on ports. So just by pretending that there is a captive portal on the network that I'm providing, then I will be able to do almost anything I want when it comes to protocols or ports if my agent is Ivanti. And for Palo Alto, it's disabled by default. The admin has to select how many seconds. It's okay, it's authorized to have some limited access to the network, but it's actually not limited at all. It's not limited to the captive portal. And the other thing that is quite useful for me is that the restriction does not apply based on the binaries. So any binary on the laptop can then have access to the network if Palo Alto considers that there is a captive portal on the network. My favorite attack, which can be related to a kind of configuration issue, but you will see that sometimes you do not have the choice. Trusted network detection. If the agent needs to find if we are already on the LAN or not, there are some strategies to do it. On the vulnerable versions of this algorithm is only looking at all these values there. So by just having some DHCP offers, it will check maybe the DNS suffix, DNS server IP, DNS PTR record, or a DNS-A normal record. So that's trivial to spoof, actually, because I can pretend I am a DHCP server, and then I can send all the values that are expected. So this is obviously what I will try to do. I will try to understand, to guess, to read in the files, in the logs, in the settings, what are the expected value, so that the agent will believe it's on the local network. So I give an example there. VPN.defcon does not exist, but still, it's happily considered that the network is available and that we are on a trusted network, even if this network absolutely does not exist. But by doing this, I have unlocked the full access to the network, so I'm happy with that. Again, one important thing to say, some agents have better ways to detect if we are on the local, on the trusted network. It relies on TLS hash signature, but it's not very convenient, and I did not see this implemented frequently in the wild. I will give a practical example with Eventy, which only provides methods to detect the trusted network that are vulnerable to spoofing. So on the top right, we have an extract of the settings file. And you can see there, it will explain the kind of connection and so on. And then we have the connection policy. It's a kind of Boolean statement with some values that are expected or not. So just by reversing the Boolean logic of this setting file, we can pretend that we are the trusted network for Eventy. And it's quite easy to do because all the values there are just values that you can push by with some DHCP offers. So I'm giving one example with DNS mask, which can be used at the DHCP server. I will use my interface to the victim. I will have some command switches there just to make the attack more convenient, and I will just give it what it expects. So host record, we need to have DC bank local that resolves to this IP. DHCP range should match as well, and DHCP option for the DNS server IP. And if I do that, then the agent will believe that it's on the local trusted network, and it will not trigger the connection to the VPN gateway, and it will completely unlock the network connectivity of the device. So I'm happy because now I can do whatever I want. Of course, the main issue is that with Eventy, you have no choice because the only criteria that you can have are DNS server, DNSA records, or interface IP range. So you are forced to use this kind of combination. Even in a complex Boolean statement, it will still be spoofable in any case. The same, almost the same attack with Palo Alto that works exactly the same with Cisco AnyConnect, but I'm not going to show three examples. Again, with Palo Alto, it's just a bit different because the settings are encrypted. Nice. But in the logs, the values are in clear text. So just have to find at somewhere else, and you will find what is expected there. IP this value and host this value. For Palo Alto, it's a PTR record, so it's, the reversed order. So I just have to precise in my configuration. I can use DNS mask with the command line or with the configuration file. I will give it what it wants. And then we have the spectacular connected internal. You are on the internal corporate network, which is obviously not true. After version 6.1, Palo Alto implements better ways to do this, which relies on the TLS hash signature, which is much better, but maybe not so convenient. So, okay, I'm done with the naive attacks. We did not even need to reverse engineer anything. We did not even need to understand how it works behind the scene, and we found some attacks that work. Yet, we have some discrepancies. Between all the agents, we found some attacks that work, that maybe we cannot easily explain why it works like that. So we need to dig a bit deeper. Now we will need some admin privileges. So far I wanted to find we exploited some things for which we absolutely do not need any privilege. Now we are going to inspect how this control is implemented within Windows. So we will need admin to exploit that or to explore how it is being implemented. But the objective is, of course, to find some attacks that then can be exploited without privileges, okay? So, behind the scene, I need to speak about the Windows filtering platform. So, WFP is a kind of a platform that consists of hooks in the Windows kernel, and that will allow developers to implement a lot of useful things with the network stack. So you can have your own filters, you can implement a lot of things, you can even work on RPC, you can work on IPsec. It's quite flexible. You can do a lot of things. There are some userland components. We have this specific DLL there, more on that later. And then, of course, all of this will speak with the kernel because all the filters that we will implement will end up being dealt with the kernel. What's important to note is that WFP is actually being used by the Windows firewall, by some network agents, by EDRs as well. So it's I think it's a very interesting target. They all use WFP under the hood. Another interesting maybe it's that we can have some dynamic versus persistent filters. So depending on the agent, again, they did not choose to implement always on in the same fashion. Some decided to use some dynamic filters, meaning that if you reboot the machine, all the filters will disappear and they will need to be committed again once the machine boots. And some others decided to have some persistent filters where even if you reboot the machine, even if you kill the binary, the process, the service, then the filters will remain. So it's another thing to keep in mind. Important concept of WFP. Again, it can be a bit complex, but let's focus on what is important for us in the context of bypassing always on. We can have a provider that will provide with some filters. We can have a session to the kernel, let's say, to put it in a nutshell. You have some layers about outgoing TCP connection, inbound UDP, or this kind of things. Those have a network meaning. Sublayer that you will do if you want to group some of your filters. And most importantly, we have the filter itself. So this is where you will decide that, okay, I will authorize an outbound connection to TCP this port if it comes from this user or this binary. So it's quite flexible. There is a nice granularity. You can implement some firewall rules based on the user, the context, the session, the binary, the path, on a lot of things. So it's quite flexible. The API functions that will be interested is engine open. When you create a new session to commit new filters to the kernel, you have provider add if you want to add a new provider, if you want to declare yourself, sublayer if you want to group your filters, and then the FWPM filter add for each filter that you want to commit to the kernel. There are some nice tools that are already there and that will allow you to inspect all the filters that you have on your machine. One is bundled with Windows already. It's NetSH. So if you type in NetSH WFP show filters or state, then you will get a big XML file on the right with a very nice description about everything that has been committed to the kernel. So you will find most answers in this output. It's well explained, but I will give some tips to analyze it because it's huge. Windows will commit thousands of filters in addition to all the third-party software that you might have that will also commit their own filters. It can be interesting. There, I just give you the example of the most important blocking rule. So it's a PulseSecure rule. It will block everything going out in IPv4. We can see that we have no condition. So it's the final rule in the firewall, and we have an action of block. So if we manage to find a way to disable, to delete this filter, then we will get our connectivity back. But that's just the output of the NetSH show filter. Other people develop some scripts or tools to play with WFP. My two favorites are WFP Explorer by Pavel Josifovich. It's a graphical tool, and it's very useful if you want to play with it, if you want to look at the filter, and if you want to delete some filter. So you can do some right-click, and you will be able to delete it. James Forshaw, in his suite of tool, NT-Object Manager, also implemented some things to inspect WFP. We will use that later. Get FW filter will actually give the list of all the filters that have been committed to the network stack. And for the rest, well, WFP is an API, so you can implement anything you want. You can add some filters, you can remove them, you can inspect them if you know the C++ API. It's well documented. It's a bit complex, but everything is documented. Just one little trick. LibreOffice, OpenOffice on Excel are able to import and properly interpret the XML file that is the output of the netsh command. You will get a nice tabular format there with one line per filter. So it's already quite convenient if you want to find some exceptions on some things that might be exploitable. Let's find some exploitable filters. But before that, I said, oh, just type in this command and you will see everything. No, actually, I was not really lucky when I started this research because I started with the most complex example because Cisco decided to hide the filters when they are committed. So I knew that the filters were there because the connectivity was not there. I could enable some non-default audit policies to have a look at all the filters that were committed. This is an example of filter that is being committed. It has a name, we have the layer, we have everything. But yet, when I wanted to use the tools to inspect all the filters that are already there, all the Cisco filters were not there, and I could not find them. But by using the get FW filter by James Forshaw, we can see that we have this weird error, access denied, even though I'm administrator, and even if I get some system token, it does not work. So I had to write some FreeDA scripts to try to trace all the filters while they were being committed to the network stack, because otherwise I could absolutely not have a look at all the filters that were already committed, and that would prevent me to have my connectivity. So just a few minutes on that. Cisco decided to do a nasty trick. They decided to actually use the security descriptor, which is optional. And they decided to only allow some specific identities or accounts or privileges to read the filters that were committed. So if we look at the structure there, and thanks to my FreeDA scripts, I could dump all the parameters of the filter add function. And if I dump the values of what is pointed to by the pointer to the security descriptor, then we can get this nice structure, which is a nightmare to parse. So instead of parsing it by hand, we can use the convert from tool as well as the new NT-security descriptor, again by James Forshaw. We can translate all these values into the proper structure of a security descriptor, and then we can see there that the system account does not have a read access to the filters that are committed by Cisco. If you want to have some read access, then you need to have the local service value in your token. So now I just get the answer that I need to pretend I am a local service before I can read the filters that are committed by Cisco. So again, thanks to a discussion I had online with James Forshaw, who was very, very keen to help me on that one. He actually wrote some of the lines we have there. So if I try to get the list of filters committed by Cisco, it will not work. I will get no result. But then if I precise that I want to open a session to the WFP engine, and if I precise that by the way, I am local service as well, then I get the list of all the filters that were committed by Cisco. So again, a kind of a little trick. And unfortunately, I started with that. So all my FreeDA scripts were completely unnecessary, but I learned a lot. Another technique to do that is WFP allows administrators to first become owner of an object before you can change the ACL, so before you can change the access control list. So this is something that I wrote. It works. The other thing that is a bit more simple, if you can use FreeDA, is just to hook the function and to replace the pointer to the security descriptor to null. Just going to give an example on that. It's very easy actually. So I'm just finding the function FWPM filter add from the DLL of WFP. Then I just need to find the actual value. So it will be the second argument. I'm just putting there the structures as a comment. And by just doing that, I will simply define that, okay, as from now, the pointer to the security descriptor will be 0, will be null. And just by doing that, all the filters that will be committed will not be committed with this ACL that Cisco shows. Now I can inspect all the filters that were committed by Cisco as well. Now that I have a possibility to read all the filters on how they are implemented, we can have some answers to our questions. The first one, I barely mentioned it, but if we can use UDP 53 for DNS, maybe we can use UDP 67 for DHCP. But it didn't work quite well. The reason behind that is if you look at the filters, then you will need to specify the UDP source port as well, which you cannot do if you do not have privileges on Windows. So this is why it did not work. Again, if we can use UDP DNS, maybe we can use TCP DNS. No, that's because all the filters that will allow these packets will only be defined for UDP. And so on. The same, Eventy, we could not use DNS tunnel nor UDP 53. It's because for Eventy, all the filters require that you are running as system if you want to use these protocols. So I wanted to discuss about the specific issues. So this is what I prepared just for you. If we look at all the restrictions in the filter that we can find, some editors made some rules that are a bit too lax. So, for instance, for Eventy, we have a lot of the rules that only apply to the system process. So, meaning you have all the authorized connection that can be performed, that can be used if you are system, and otherwise it's blocked. But we have a few exceptions, such as this. In this path, you have 3 binaries that you can use and that have no restriction. So all these 3 binaries can connect to the network with absolutely any protocol, any port, or this kind of thing. So depending on how the agent was deployed, app data roaming can be a folder that can be written by the end user, even without privileges. So depending again on how the agent has been deployed. So the situation is, let's try to get some connection, and because the tunnel is not established, I will not be authorized to do that. I have all the filters that will prevent me from doing so. So I get this, fail to connect to blah, 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 indeed, because I have some filters that will prevent me from doing that. The exploit, it's very simple. I will just replace the binary with what I want. So I will just move the curl exe to this location, and I will name it Pulse Secure client, just because it matches with this exception. And obviously, since this filter is only defined on the name, on the path, then I'm completely authorized to use my new curl just with this new name in this new folder, so that I can have my connectivity. So that was one example for Eventy. Another fun one, with again Eventy or Pulse Secure, is when a captive portal is detected, we get some new filters that are being committed. Of course, by default it's completely blocked, but if the agent determines that you have a captive portal, then it might still authorize you to connect to the web page so that you can put your credentials, your credit card, or whatever you need to get the authorization from the captive portal to connect. There is only one filter. There are several filters that will be committed. It's MSH WebView 2. It's the actual component that you can use if you want to have some, a built-in web view in your own program. The path to this binary is this one. And again, they decided to put no restriction at all. As long as you can have some code running as MSH WebView 2, then you will have full network access, even if the tunnel is not established. And if you want to do that, well, Microsoft publishes some very nice example in their own SDK, WebView 2 samples. You have something that you can compile quite easily, and it will actually allow you to use MSH WebView 2 exe. And since it is a kind of POC, you can have all the features that you want, and you will get a full-fledged browser if you want. But now we have all the possibility to use any features of HTTP or WebSocket or whatsoever, because we have the full control of the kind of browser that we can have. And because of the lax filter, we are now free to do it as well from our own binary. Okay. At the conclusion, I have this table that shows how different the agents can be when it comes to the implementation of VPN always on. So if you consider that all columns there, we can always find an attack that will work. So the direct consequence of that is no agent is perfect, and you will always find at least one attack that will allow you to completely bypass VPN always on. So I think I explained most of them. Sometimes it requires some vulnerable configuration. Sometimes it will actually work out of the box and you do not need anything. And indeed, you will have some discrepancies not only between the vendors, the editors, of course, but you can also have some discrepancies between the versions. So when Palo Alto reached out to me to discuss about my findings, they said that, oh, by the way, we updated our agent. They did not want to send the latest version of their agent. I have to find one myself. But I realized that they had some updates that was interesting, like version 6.1. It's a good update because you can now have some check for the trusted network detection that is not spoofable. So that's nice, great. However, what they have done in addition to that is actually add a new filter that will allow TCP VC3 to work. So it's up to you to decide which vulnerability you want with this one. Again, up to you. More on the Palo Alto discussion. So we just try to give some not so high fidelity summary of the discussion. Captive portal detection is disabled by default. Indeed, that's something that I wrote by mistake in my first slides. Trusted network detection is improved. Indeed, I could not test in practice at first, but as per the documentation, indeed, it seems that it's fixed. Now, when it comes to the unrestricted UDP port, they say no, it's not vulnerable. I said yes. They said no. I said yes. Yeah, they realized that I was not wrong. But then they consider that it's not bidirectional. But that's something important that I did not explain. If you have a rule that will allow for some outbound connection, well, WFP is stateful, so the packet that will come back will be authorized as well. This is documented. And again, their final sentence, this behavior by itself is a feature evasion rather than a product vulnerability. Not judgment. Yet, they are working on it, and they will release some updates that will hopefully fix the issues. A few seconds on the recommendations. I don't have time. It's a bit boring. I worked a lot to try to find some ways to detect it or to prevent it. It's not easy at all. In my opinion, the best way to prevent this kind of attack is actually not allowing your employees, your staff, to connect to dangerous Wi-Fi hotspots and tell them to use their cellular network instead. Again, up to you, but otherwise all the other techniques can be applicable. Key takeaways, always on can sometimes be a bit off. As you can see, VPN agents are not securing the always on feature in the same way, and none of them is perfect. We already found some naive attacks. We did not need to understand how it works, how it is implemented, to find something that works. And yet, you can try to analyze all the filters if you want to find the truth behind all this behavior that we can have on the network stack. In my opinion, TND spoofing is still the best technique. It's the most convenient because you have completely unlocked the network access, so you can do everything you want. Most answers are found in the documentation, and you can find very nice open source tools that will give you all the answers that you need on that. And in addition to the issues that I found in the implementation of these agents. You can also have a lot of issues coming from the way the VPN agent has been deployed. So I've been doing a lot of pen tests on this kind of environments, on controls, and sometimes you have even the settings file that were the access control on the settings files were changed, and that would allow the end user to actually delete the always on control, or you can change the settings. So it's also something that you might need to consider if you want to improve your posture, if you decided to use always on, which is still a very nice control to have to prevent some other attacks. Thank you very much for your attention.
Thank you very much, Maxime. Very nice talk. I will have time for questions. Q&A session. Who want to ask something? Nobody. One question there.
Hi, thank you for the talk. A little question about remediation. Cannot you do with Windows firewall rules, like saying only the VPN exe can access the internet, and then only all others can only access the internet through the VPN interface?
Yeah. So indeed, the question is about when it comes to remediation, maybe you can add your own filters. And that's, in my opinion, the best way to do so. The only issue I anticipate with that is you will need to really have a look at what are the filters that are already implemented precisely by your agent to try to compensate. And indeed, you will have to find some filters that will not, I would say, intersect with all the rules that are already there. But that's indeed, in my opinion, the best way to deal with that. Look at your agent, look at the filters, and implement your own rules. You can do that with the Windows firewall. You can define some things, or you can be a bit more hardcore and use the WFP as well. So you will just need to compile your own binary, and then you can even decide, depending on your own staff, teams, departments, you can even be flexible with that. That's how I will try to fix it.
There's a question here.
Hi, awesome talk. Just building on the previous question, is there any way to kind of build on these other techniques from a blue teamer's perspective, which is to say, if there is supposedly detection that you're in a trusted network, that you could add authentication to some sort of Active Directory simplistically. Is there anything that is in WFP or WPF, or in any of these agents that implements that?
Yeah, great question. So indeed, again, on the kind of compensation about the current situation, unfortunately, you are stuck with the willingness of these vendors to do things properly. You can indeed find a lot of what you need in the WFP standard. And if we go back to what it proposed, you have actually IPsec as well on RPC, on everything. So if you want it, and if you have a very nice AD configuration and you can have some nice tiering in place, you can definitely try to force some IPsec to happen. But then you can end up with a chicken and egg situation. First, if you want to detect something, you have to keep in mind that if the red team has access to the machine and if they control the network, you will never get the logs back in any case. So that's one way that's one thing to keep in mind. The other thing to keep in mind is if you need to establish some controls, some filters, depending on the identity of the user, maybe, then you will need to make sure that, okay, you probably need to reach out to the domain controller first. So you need to have the tunnel established before. So you will need to think about what are the filters I could try to implement to commit that could allow a direct connection to the tunnel before or after my risks might occur. Another idea that was proposed is you will have an external VPN gateway for all the people that are outside of the network, but inside the network you will have an internal VPN gateway. This is also something that can work on the direct consequence is you will not have any trusted network detection to do because you will always be connected to either one or the other VPN gateway. That's another way to think about that. Yeah.
Cool. Thanks.
Thanks.
Thank you. Any other question? No, thank you. Thank you, Maxime.
Thank you.